A projectile is any object that has been thrown, shot, or launched into the air. The motion through the air which this object takes is known as the projectile motion. Today we will be analyzing the projectile motion of a golf ball in the air. To demonstrate this, I will hit multiple golf balls with many different clubs. The first club that I'll be using today is a 60 degree. It's also known as a sand wedge, and when hit it usually launches the ball higher and shorter, so used for short distance shots. And when the trajectory is higher and shorter, it has a more distinctive peak than, say, using a driver. And the reason for the arrow on the screen is just to help visualize the ball, as it was kind of hard to see with the multicolor background. The second club that I'll be using today is the 9-iron. And with the 9-iron, it has about a 35-degree angle in relation to the ground. So it's going to launch the ball a little bit lower and a little bit farther than the sand wedge, but not as far as some of the other clubs, like I'll demonstrate in a second with the 5-iron. And the final club that I'll be demonstrating this concept with today is a 5-iron. And a 5-iron is about 15 degrees in relation to the ground. So it's going to launch the ball a lot lower, a lot straighter, but a lot farther than the 9-iron and the sand wedge. So this club is used for much longer shots and has a greater horizontal velocity than the other clubs that I've tested. And here I'm showing some close-ups of the face of the club so you can kind of get an idea of the face lengths and the degrees in relation to the ground of the club to show how it launches the ball off the ground a little bit different. So this is the 60 degree. This is the 9-iron, the about 35 degree club in relation to the ground. You can kind of see that there. And it launches the ball a little bit lower, than the sand wedge, but a little bit farther. And here's the 5-iron, about the 15 degree club in relation to the ground. This club is very thin. You can kind of see that here. And there's the 15 degrees in relation to the ground. And it does launch the ball much lower, but a lot farther than the other clubs tested. And here are some shots with the 60 degree. Here's the 9-iron and the 5-iron to kind of show how each club lines up to the ball and kind of get a better visual on each angle as the club face approaches the ball. Alright, so now that we've got all the testing out of the way, let's draw it up on a whiteboard and explain some of the physics that's involved in each of these shots. And here's a terribly drawn golfer. And right now I'm representing the horizontal and vertical velocities within the full path. And actually all of these horizontal velocities are going to be equal because in this case air resistance is negligible. And up here at the top of the downward facing parabola, the vertical velocity will be 0 as the ball has reached its peak for just a split second. The horizontal velocity will continue and the ball will hit the ground at the exact same speed as it launched off the club face. And I'll demonstrate the same process again using the 9-iron this time and try to estimate the trajectory of that club. Here's another terribly drawn golfer as the ball reaches the peak. Again, it has no vertical velocity, but the horizontal velocities do in fact stay the same as air resistance is negligible. Now I'll do the same thing with a 5-iron. I'll draw another golfer here and show the path of a 5-iron being hit with full power. And again, the horizontal velocities will all remain the same, but at the peak the vertical velocity will be 0. And also the vertical velocity differs as it goes up towards the peak and down towards the hole.